Okay. This is a slightly different version of these two classes. So we're going to have the same functions, but we are going to be making the variables private, right? So here in the base plus commission employee class, we made that base salary variable private. And then also at the top level, meaning the commission employee, same functions, but we also made it private here instead of protected. And now the commission employee, right, that one, we could really do the same as before, since that's the top level class. But difference here is that with some of these now, even within the function itself, it's just calling its own local function. So for example, earnings here, calling get commission rate and get gross sales instead of just returning the referring to those variables directly. But in particular, we're going to see how we can handle this in the child class. So again, this is for now, this is just the top level class, meaning the CE class. So we could have still, within each of these functions, right, we could have still, for example, had earnings, access commission rate and gross sales directly, but that's one thing that's changed here as well, is even within its own class, even with its own direct number variables, we're still, for example, calling functions when possible. And then we're doing that here with the toString as well. And then in the child class, or the base plus commission employee class, we're going to be doing the same thing. But one thing that comes up now is, for example, in the earnings function, how are you going to go about calculating the earnings? Because before we were saying things like base salary plus and then commission rate times gross sales, right? We were directly accessing those members. And now we're not able to do that since they're private. So another thing that you could also do would be, and again, you'll see here that even with things like the base salary, which of course we have access to since that was directly defined inside of the base plus commission employee class itself, even there we're calling the function instead of accessing the variable directly, because we hit on that point back in chapter 9 when we said that it's still a good idea in some cases even to do that within the same class. So that way, if there is some sort of change that's made, then by having, for example, the earnings function call get base salary instead of accessing salary directly, if we end up making some change related to how the salary is implemented, then that minimizes the number of functions that we'd have to change to work with the new implementation of salary. So, it's always good to think about those details as well, even within the same class, right? Minimizing how many places where you might have to change things. But one way that you could implement this would be something like call get base salary. So just call the base plus commission employee's own local get base salary function, and then plus, and then call the, get gross sales times get commission rate. In other words, very similar to what we did before, but with 3 function calls instead of accessing the 3 different variables. But here you'll notice that we chose to do it in a little bit of a different way. But in particular, notice what we're doing here is 2 function calls. We're calling get base salary, which is the local function defined within the base plus commission employee class, but we're also doing this called earnings. But what we're doing really is we're calling the earnings function from the commission employee class. Because if we think about how the earnings function at the top level, meaning the commission employee level, is implemented, that's really giving us what we need for the remainder of this calculation. Because in particular, the earnings function at the CE level or the commission employee level is already calling each of those 2 functions, the get commission rate and get gross sales, and then returning the product of those 2. So rather than doing that again, at the bottom level or the child class level, we can just take advantage of what's already there and call the earnings function. But what you saw in that function call is that we also needed the scope resolution operator, because the whole idea is we were inside of the child class level, the base plus commission employee level, but our goal was to call the earnings function from the top level or the parent level, meaning the commission employee level. So, if we didn't have the scope resolution operator and we just said something like get base salary plus earnings, well, that's certainly going to be a problem, right? Because that would mean that we'd be trying to call the base plus commission employee earnings, which would be recursion, right? Essentially infinite recursion, since the function's not set up to, have a base case and stop and all that. So that's clearly not going to work, but we know how the scope resolution operator works. And we know that whenever there's an issue of conflicts with scope, we can always resolve that with that operator. So by putting the commission employee : now we know for sure what it's going to do, right? It's going to call the earnings function from the commission employee class. Because again, if we didn't have that, then it would try to call the most local version, which would be the one from base plus commission employee itself. So we do need the scope resolution operator there. But as long as we have that, then it's gonna call the correct one. So in other words, call get base salary, which is defined in this same class. And so that's just going to return the salary. That's the first part. Then we're going to turn around and call earnings from the other class, from the commission employee class. So now we're going to come here, and then this calls in turn two functions. So we call get commission rate, get that, and then we call the get gross sales and get that. And then we put it all together to finally calculate the earnings for that type of employee. And again, that also makes sense here, because so the whole reason why we had to redefine these functions is because there's a slight difference in terms of how we need earnings to work in the commission employee class versus the base plus commission employee class. And as we'll see in a moment, it applies in a similar way to the toString function. But it still builds off of what's already being done in commission employee, right? Because we know that a base plus commission employee still has the commission rate. So all that part still applies. It's just on top of that, they have a base salary. So why not use what's already being done in terms of the calculation from the earnings function in the other class, right? We might as well take advantage of that. Because it shortens the code here as opposed to having the three separate function calls. And we see the same idea here also with the toString function, perhaps even more so, because before, what we were doing in the other version of these two classes, what we were doing in the toString at the child class level, meaning BPCE, is because we had direct access to the variables, we were doing things like output and then first name, last name, social, and so on and so forth. Here, we don't have access to any of the private members from the CE class. So one way that you could do it would be to have a longer stream where you do things like call get first name, call get last name, call get social. But the idea is we don't really need to do all that, right? We can once again build off of what has already been set up at the top level, meaning at the parent class level, because we know that the toString function in the commission employee class is already dealing with things like the first name, last name, social security, gross sales, and commission rate. So why not just take advantage of what's there and just do a little bit more on top of that? And that's exactly what we're doing here in the toString function in the child level. So the first thing that we do, right, is we call the toString function from the CE class, the commission employee class. And if we go back to there, we saw how that one was working, right? So this is the one that calls the 5 functions for the 5 member variables that come from that class, and then we return that as a string. So we're going to return that back now to the child class level. And then the only thing to do beyond that is to deal with the base salary, which we did by calling that function. So now we've also, there's several advantages when we think about this version versus the previous version. For one thing, we now don't have to worry about the situation of a fragile or brittle class, right? Where making some sort of change in the commission employee class is going to suddenly break the base plus commission employee class, right? Because now the base plus commission employee class is never directly accessing variables anyways from the commission employee class. Everything is going through the functions. So that means if we change some sort of implementation detail, like maybe how the earnings function works in the commission employee class, that's not going to change, right, anything in the base plus commission employee class, because it just needs to simply call that function. I mean, the only way that you would have a change in the child class is if you did something like maybe change, for example, the return type or the number of parameters of the function. Like if we made earnings function in the commission employee class, now a parameter is required. Well, then of course you couldn't call it like what we're doing here with no parameters or empty parameters. But assuming that we're not changing things like that, but rather just changing the body of the function, right, from the other class, like we're changing what happens in the logic of the earnings function, but we're not changing things like return type or parameter list, well, then we don't have to make any changes at all for the child class, meaning the base plus commission employee class, for it to be able to work with the new version of the commission employee class. But again, if we're accessing variables directly, then you run that situation where changing some sort of implementation detail in the commission employee class is now going to cause the base plus commission employee class to break because it doesn't work with the new version. So we're avoiding that also by keeping things private, right? We're avoiding that problem of what we call, and again, we call it sometimes a fragile or brittle class. So we're avoiding that. And we also kind of cleaned up our implementation here too, in terms of taking more advantage of what's already been established for us. Because again, in the previous version, for example, the earnings function, we were referring to all three variables separately. So things like multiplying sales by commission rate. And then in the toString function, we were individually referring to all of the variables from the parent class. But here we're taking really full advantage of what's already been done for us. And so in that sense, with both of these two functions, we don't have to directly refer to anything now from the parent class. We don't have to refer to things like the commission rate or the sales or the first name and last name, because we just simply call that same function from the top level, from the parent level, and that's going to handle all of those details for us. So we've also cleaned up our implementation by taking advantage of what's already been done in the earnings and the toString functions at the parent level or at the top level. So we made the actual implementation of these two functions a little bit cleaner, right, in the child class, meaning the base plus commission employee class, compared to the previous implementation. So again, we've made some improvements here to the general approach. And with this version, the application program, right, is the same idea, right? Just running that same application program, but now with the new approach or the new version of this. And so we just once again test out the different functions here and print everything out a couple of different times. Okay, so like before, we get the same output. Okay. So now we've hit on a lot of the really the key fundamentals with inheritance. We've seen the basic idea. We've talked about things like even though there is the access specifier protected, like with many things in programming, just because something is possible, right, doesn't always mean that it's the best idea or the best approach to take. So we do have protected, um, but it's one of those things that you also want to think about. Is it really the best way to go forward? So, and because we saw two different versions of this, the first using protected, the second version that we're running right now keeps everything private. So we were forced to go through the functions, but there were advantages, right, that we get as a result of doing that as well. Was there any? No. Was there any changes in the application program? No. So this was the same. Yeah, this was the same application program. Yeah, good question though. But yeah, the idea was we just wanted to run essentially run through the same logic, but with the new version or the new way of implementing these two classes. All right, so now we'll look at question, but then now that we have the basic idea down in terms of what inheritance is and what it really means, now we can think about literally going to the next level, meaning going to 3 levels of inheritance. And along the way, we'll also see how things like operator overloading can be thrown into the mix as well, right? So how can you handle operator overloading when there's also inheritance involved? So we'll see how to combine, right, these two concepts together. Um, so we'll be looking at a project that has 3 classes: um, person, employee, and supervisor. So where in this case, person would be at the top level, and then employee would be at the middle level, and supervisor would be at the bottom level. Because we know in general, right, with an inheritance hierarchy, from top to bottom, right, you're going from a more general type of class to a more specific type of class, just as it worked here, right? Commission employee was a more general type, and then base plus commission employee was more specific, because you have the two sources of income. And it'll be a similar idea when we're looking at this 3-level project, in the sense that person would be the most general class, then you have the employee class in the middle, and then you have a supervisor, which is even more specific because they're a specific type of employee. But we'll see that the general idea of 3 levels of inheritance, and also some operator overloading, and how that's going to work out when it's combined also with inheritance. Because one thing that you have to think about is if you're overloading an operator, for example, at the bottom level, in this case, the supervisor level, you have to think about, well, how is that function going to call the same overloaded operator at the next level up in the hierarchy? So for example, how is that operator going to call the same operator function, but at the employee level, right? Because that's the idea, that the inheritance applies also to the overloaded operator functions in the same way that it would to other things that we have in the class, meaning other functions. So we'll see how that's going to work out, and then for your assignment this week, right, you're going to be building off of the assignment from last week, but you're going to be overloading operators, right? So you'll be combining inheritance with your account, right, savings account, checking account. You're going to extend that to now also include overloaded operators. But we'll look at a question first, and then we'll start looking at that example. Okay, so look at a conceptual question here on inheritance. So we have these two classes, shape and rectangle, that we've defined. Now the actual body of the two classes is omitted, right? But then the question here is just says, for which of the options below are all the statements true? So like before, your polling window should have just come up, so you can answer this as soon as you're ready, but that's the question that you'll be answering here. So just a question on inheritance and the relationship between these two classes. Okay, and again, you can answer as soon as you're ready. Okay, so about 30 more seconds, and we'll start and bring up the results here. So just want to think about the relationship between these two classes. But go ahead and answer if you haven't, and we'll start here in a moment. Okay, looks like most chosen was D, and then a few on B and C. Okay. And so in this case, the shape class was the top level class. Um, and we'll talk about when we get into polymorphism, which builds directly off of the concepts of inheritance. We'll eventually talk about things like an abstract class and what that means. Because in this type of situation, shape is what we normally would call an abstract class, which we'll talk about that in chapter 12. But here, shape is the parent class, and rectangle is the child class, and it's publicly inheriting from the shape class. And this is a question really about how the is-a relationship works between these two classes. And so let's start with option D there, because option D is saying really three things. A shape object has a shape part, a rectangle object has a shape part, a rectangle object has a rectangle part. And so getting right down to the core issue of what really does the is a relationship mean. And the idea is that when we have an inheritance relationship like this, the is a relationship goes in one direction. But not both directions. And we'll see even more what that really means when we get into polymorphism in chapter 12. But so it only goes in one direction, meaning that in particular, when you think about and you're visualizing, a shape object in memory, there's not going to be anything related to the rectangle class for that shape object. So, and the body of both of these classes are omitted here, but when you think about a shape object in memory, whatever member variables that we declare in the shape class, those are going to be the things that the shape object is physically storing, and that's it. Because a shape is not a rectangle, right? The is a relationship does not go in, never goes in both directions, right? So we would not say that a shape is a rectangle. But when we're talking about a rectangle object in memory, it's going to have in terms of the amount of space that it takes up, it's going to have space certainly for each of its own locally defined member variables, but also it's going to be physically storing the things that are coming from the shape class as well, because that literally is what we mean when we say that a rectangle is a shape. It has everything right from the shape class. So, in that sense, it's also a bigger object. Well, depending upon how the shape class is implemented, we'll talk more about different ways of handling that really when we talk about polymorphism in chapter 12. But if we're just talking about similar to what we've been doing, maybe the shape class has a few member variables, maybe the rectangle class has a few member variables. It means that the rectangle object in memory is going to be storing all of that. Because it has both parts, right? That's why we would always say that a rectangle object isn't just the rectangle object itself, right? It's also the part that's coming from the shape class. And that's also why we know that when we're talking about the constructor in the child class, remember we said the very first thing that's going to happen before anything else is that you have to call one of the base class constructors or the parent class constructors. So for example, in the base plus commission employee and commission employee example, the base plus commission employee constructor has to call the commission employee constructor to initialize the commission employee part of the base plus commission employee object. But of course, it doesn't go the other way around, right? And in fact, we couldn't try to go the other way around and do something like have the commission employee constructor try to call, the base plus commission employee constructor, because it doesn't know about it, right? Because that's the top level class. So the is a relationship goes always in one direction. So in a general sense, the child class, right, always has the base or the parent class as part of it, but not the other way around. So based on all that, then yes, option D there, D as in dog, is going to be correct. So a shape object only has a shape part, but a rectangle object is going to have both parts. So yes, D or D as in dog is going to be the correct one there. And we're about to start looking at 3 levels, but the same idea extends to however many levels you have in your inheritance hierarchy. So now we can start thinking about things like a grandparent and grandchild class, right? When you start having more than just 2 levels, but it's the same idea. So meaning that when you're looking at a grandchild, if we want to call it that object, meaning the bottom level of the 3 levels, well, In this case, we would say our three classes are person, right, employee, and then supervisor. And the whole idea is that a supervisor is an employee, right, is a person. So that means a supervisor is an employee and in turn also is a person. So it propagates up, right? Everything propagates up from the bottom level up to the top level. So meaning that a supervisor object, right? A supervisor object then has three parts: the supervisor part, the employee part, and the person part. The employee object, the middle level, has two parts, right? Two parts, an employee part and a person part. And then the top level, right, the person has just the person part. So we can extend this to whatever situation we need, right? You can have three levels. You can also go horizontally in the sense of any particular parent level class can have multiple child classes. In this case, we don't have that because it's just, three different levels. Each class is on a different vertical level, but you could also have multiple classes at the same level, right? So meaning at the same horizontal level as well. And any combination of those two is certainly possible. So we can model really any situation that we need to model in terms of an inheritance relationship, just depending upon what exactly it is that we need to model. So when we look at polymorphism in chapter 12, we'll also look at a case where, so there's inheritance, but there's also polymorphism, and there'll be multiple classes at the same level. So we'll see that case come up in chapter 12, and we'll build off of the commission employee and base plus commission employee example by adding a couple of extra classes, and we'll see how that's going to work in chapter 12. But for now, we have just three levels, and each class is at a different level. Now, a couple of things that we said here, right? We said that a supervisor is an employee, and by extension is also a person, since an employee is a person. So the other implication there is that you can have classes, right, that are acting as both a parent and a child simultaneously. So think about the middle level of this three-level inheritance project. On the one hand, right, the employee class is the parent of the supervisor class. On the other hand, it's the child of the person class. So in general, right, it's possible for a class to be acting as both a parent and a child. And we can go as deep as we need to vertically. So you can have things like, a great grandparent class, or a great grandchild class, or a great, and so on and so forth. So you can go in a vertical sense, right? You can make it as deep as you need to. In a horizontal sense, you can make it as wide as you need to. So meaning you can have multiple classes up at the same level that all inherit from the same parent. But we'll see how this is going to work now in terms of three levels. And along the way, we'll also see how operator overloading can be incorporated as well. All right, so we'll start here from the top and work our way down. Oh, yeah, good question. Yeah, because we were talking about, the situation where, well, one way you could think about it is maybe the word siblings. So for example, there's like one parent, and then you have these different child classes that inherit from the same parent. So you might think of those classes as siblings, if we want to use that terminology. But so we can have that situation, meaning multiple child classes inherit from the same parent. So we might call them sibling classes. And then, a question about, can a child have multiple parents? Yes. We're not really going to focus so much on that. It's a little bit more involved, but that's called multiple inheritance. And it is something that's allowed in C++. So meaning that a class can inherit from multiple classes at the same time. The main thing being that you just have to make sure that there's no conflicts in terms of how the how the child class is working off of both parent classes at the same time. But yes, that kind of a thing where a child has multiple parents is also allowed, and but it has a special name. We call that multiple inheritance. So you can do that. You know, you have to be careful about certain things with that, but it is nonetheless possible to do multiple inheritance in C++. Yes, it's a good question. Yeah, we'll focus mainly on single inheritance in the sense that our examples will, in all cases, the child class will be inheriting from just one class directly. Now, if you think in an indirect sense, even here, right, the supervisor is ultimately getting things from different levels. But it's not multiple inheritance because, for example, the things from the person class are inherited into the employee class and in extension, right, inherited into the supervisor class. Whereas multiple inheritance, in terms of what that really means in C++, that means directly inheriting from, so think of it like a mother and father, right, if you maybe want to use those terms, but directly inheriting from both classes. Whereas here, things from the person class are really kind of indirectly, right, being inherited into the supervisor class because they're going through the employee level first before they make it down to all the way down to the supervisor level. So in that sense, we're not doing multiple inheritance here in this project. But so the top level class is the person class. This is our most parent or top level class. But again, there's going to be some operator overloading here. And we'll see how this is going to work when you have multiple levels that you have to work off of. But only a few things, right? It's not going to be as extensive as the chord class because we're just kind of showing the basic idea, right, of how this works. And then you'll be using that when you build off of the savings account, checking account assignment from last week, right, to now add some overloading. But one thing that we do have here is the output operator, because one thing that we're going to do in this project is be able to display the different fields for the different objects that we create. And again, so far, this should hopefully look very familiar in terms of the general setup because it's very similar to what we did right in the coordinate class. So the keyword friend there, return type OStream ampersand, right? Because it's going to be, for example, reference to cout. Name of the function is operator less than. First parameter is a reference to cout, so OStream ampersand. And then as we discussed back in chapter 10 with all the chord class examples, we know that at least for the output operator, we know the first parameter is going to be, in this case, a reference to cout, really. And then the second one is the object, right? Because one of the key points that we hit on back in chapter 10 was the whole idea when you're overloading an operator, right? One of the operands has to be an object or a reference of the class type, right? It has to be one of those two. But for the class object part of it, we can also make it constant because the object, in this case, the person object, does not need to change inside of the output operator. And as we've discussed multiple times throughout some of the previous chapters, we know that we also should really be passing it by reference and by value, right? Because otherwise you're going to end up making a copy object and all that. So, but we can avoid that by just passing it by reference here. So const person ampersand, or passed person object by constant reference. We have a person constructor here with a couple of default arguments because the two member variables here are a string for the name and the integer for the age. So the person's going to store a name and an age, and those are the two member variables. And so those can optionally be passed in. There's a destructor here, and then the assignment operator. So again, so far this should, a lot of this should look familiar because the general syntax so far at least is the same as the chord class, right, from chapter 10 in terms of the operator overloading. So for example, we talked about back in chapter 10 why operator equal usually returns a constant, so that way you can't do the left chaining and all that. So return type there is const person ampersand, and then that's also the type as for the other object, right? The right hand side object is also being passed in by a constant reference. And then the function itself is not constant since it's going to still be changing the current object, meaning the object on the left-hand side of the equal. And then there's this function print message. And then for now, we have everything protected. And then let's look at the implementation. Again, since this is the top level class, everything's going to hopefully seem very familiar. But we'll see what's going to be different when we look at the next two levels, right? Meaning the employee level and the supervisor level. But here for operator equal at the person level, just kind of doing what we would expect, really. Age equals age of the current object equals, and then we know that P, for example, references an actual person object, for example, from application program or wherever it's coming from. So current object age equals P dot age, and then current object name equals P dot name, and then return the current object through return star this. Very similar to the chord class. And then the output operator also is very similar to things we've seen in the chord class. So output, building the string with the output, and then P dot name, P dot age, and then return that. And we know that we can use that with things like cascading function call. And then our constructor here just does name N and then age A. So we set that up with some default arguments. So they have a few different ways they can create the object. And then we have a destructor that has a cout statement. And then we have this print message function that just prints out that short message that says person message. Now again, some of these things are here just so we can see when they're running, right? Like the cout statement here or the cout statement here. But notice now, because we looked at the array class example in chapter 10, right? And we talked all about, shallow copy versus deep copy. And we saw how the implementation was very different, right? For the deep copy version of the array class versus the shallow copy of the array class. Because in particular, we said that you didn't want to do what the default version was doing, right? So for example, you didn't want to do what the default version of the overloaded assignment operator is doing. But notice that that's what we're doing here, right? Because what we're doing here is what the default version would be doing. But in this case, we don't have things like a pointer to a dynamically allocated array of integers. So we're not really concerned about the whole issue of a shallow copy versus a deep copy. The issue there with that project was if you did a shallow copy, right, you're just copying the address from one pointer to the other pointer. So you end up with two pointers pointing at the same dynamically allocated, in that case, two pointers pointing at the same dynamically allocated array of integers on the heap. But here, right, we don't have a pointer as a member variable. So we're not really concerned about those kind of things. So it's okay in that sense to just do a very short, right, kind of standard thing for operator equal. So that's why this is, more along the lines of what we saw in the chord class or the shallow copy version, because that issue doesn't really come into play here. So just copy the age, copy the name, return the current object, and then build the output stream here with the name and the age. And then we just kind of have standard kind of implementations really for the other things like the constructor, destructor, and print message. So again, in the destructor, since we don't have things like dynamic memory allocation, right, there's not really anything that needs to be done, but we do have a cout statement there, so we can see when it's running as well. But there's nothing to delete or anything like that since there's no DMA, right, or dynamic memory allocation. But what about the next two levels, right? Because that's where it's going to get a little bit more interesting. This is the top level, so a lot of this is kind of what we would expect. But, if you're going to have these same, things like op equal and the output operator, well, how is that going to work, for example, at the employee level? Because, if you're going to copy one employee object to another employee object, well, you have to think about what that really means. It means we want to copy everything from one employee object to the other employee object. But what does an employee object consist of? Well, it's going to have some of its own newly defined member variables, but it also includes the things from the person class. So we have to think about copying, right, everything, all aspects. But when you call operator equal in the employee class, we can't just simply say, we can't just try to do exactly the same thing here, but at the employee level, right? In other words, something like, and we'll look in a minute, right, when we look at the H file, what those member variables are, right? So in the employee level, the new ones that are not from person are an ID number and a salary. But, going back to what we did in the person level, you can't just say, things like ID equals E dot ID or something like that, right? Salary equals E dot salary, because then you only would be copying the newly defined fields in employee, but you wouldn't be copying the person part of one of the employee objects to the person part of the other employee object. So in order to do that, we have to think about what's going to be involved, right? What is going to be involved if we want to really do that? Well, we already have, right? We have operator equal here in the person level that is designed to deal with the fields from the person class, right? We have this operator equal function that's designed to take from the right-hand side object, copy the age over to the current object, and likewise with the name. So all we need to do then is we need operator equal the employee level to call operator equal at the person level, in addition to copying the ID and the salary directly within operator equal at the employee level. So as long as we can do that, then we're going to be able to copy everything over from, meaning both the employee part and the person part, from one employee object to the other employee object. So we just need to call operator equal, right? Meaning this operator equal from the person class inside of operator equal in the employee class. And we'll see really a couple different ways, but one way will be the active way of doing that. We just need some way, though, to ultimately trigger that function call. As long as we can do that, then we can handle these things, right? So that's really what this whole idea comes down to. Oh, okay. Yeah, I'll go ahead and restart, and then we'll let you back in when you get back in the waiting room. And so we have these two member variables. And in terms of the functions that we have, right, it's essentially the same set of things that we had in the person class. So, we have the output operator like we did in person. And it's the same, notice it's the same general setup. So OStream reference parameter, const employee for the second parameter, We have the operator equal. We have a constructor here. Notice the constructor, though, takes 4 parameters, but we can think about why that is, right? Because this is similar to the example with the base plus commission employee and commission employee classes. In particular, we know that the employee constructor is definitely going to have to call the person constructor. So it should take in, it's going to take in parameters not only for ID and salary, right, but it should also take in parameters for the name and the age, right, that are coming from the person class. So we have up to 4. We have default arguments here, so there's different ways that we can create the object, but we have up to all 4 potentially being passed in. And then we have our destructor and another print message function. But now we're going to start to see how we can trigger those function calls, because it's the same, it's the same thing also with the output operator, right? Because when you think about what's going to happen for the output operator at the employee level, well, if you think about what happened at the output operator for the person level, what did we do? We did things like output, p.name, p.age. So part of it is something like e.salary, e.id, but we also want to display, right, the person part of the employee object, which means that we're going to need to trigger a call to inside of operator less than in the employee class. We need to trigger a call to operator less than in the person class. So we'll look at that as well. But so that's the idea with the employee class, and then we're inheriting with public inheritance. So we have that word public and then person after the colon here. And so now let's go and look at employee.cpp. And starting with the assignment operator. So the first thing that should happen right before anything else is we should copy the person part of one of the other employee object to the current object, right? Meaning the current employee object. And so the very first thing that's going to happen here is we're going to call operator equal inside of the person class. And now we mentioned back in chapter 10 that when you're dealing with these overloaded operators, you can always refer to them by a function name. So here we're doing this with, function call syntax. So, but we're also using the scope resolution operator, right? Because without it, it would be a recursive call to the employee version of operator equal. But we're just saying in that, in this case, person : operator equal, and then E, right? So meaning our reference parameter. So the whole idea, right, is it's going to call operator equal. I mean, we're calling operator equal in the person class, but what are the 2 arguments that we're passing into it? Well, they're the 2 employee objects, right? Because we know the current object is always one of the parameters, and since we put E here in the parentheses, that would make that the other object, meaning the right-hand side object. But what we're calling is operator equal in the person class. So one thing we can think about is, first of all, why is that okay to do? Why is it okay to call operator equal? Because in this case, we're calling operator equal in the person class, but what we're passing in are 2 employee objects instead of 2 person objects. But we can think about why that is okay. Because one thing that you could do certainly is you could, for example, in the application program, create some person objects and do things like P1 equals P2 and call operator equal in the person class directly. But if we create some employee objects, E1 and E2, and then we do something like E1 equals E2, what we're seeing is that the first thing is you're going to call operator equal in the employee class. with E1 in this case being the current object, E2 being the right-hand object. But then you're going to just turn around, right? And you're going to call operator equal in the person class with E1, the employee object, as the left-hand side object, and E2 as the right-hand side object. But that's okay, right? We know it's okay to do that, because when you think about what's going on at the person level, right, from the perspective of operator equal in the person class, right? Because remember, the person class doesn't know anything about the employee class, right? This is the top level of the inheritance hierarchy. So we don't know anything about an employee object or an ID field or a salary field, but that's fine, because from the perspective of the person operator equal, we're taking in a person object. Of course, the current object is a person object, and we're just copying the age from the other object to the current object, and the name from the other object to the current object. But why is it okay to call operator equal with an employee object being passed in instead of a person object? We have to think about first of all, we have to think about why it's okay to do that, because that's exactly what's happening, and that's what needs to happen. But it's okay because it is a relationship, right? We said that an employee is a person. So that's fine, right? We can certainly pass in things like an employee object, because when we get into polymorphism in chapter 12, and we'll see how that directly builds off of inheritance, right? Meaning we'll see how polymorphism builds off of the general concept of inheritance. What we're going to see at that point is that you can do things like, for example, say you have a person pointer, right? Meaning a pointer of type person star. Well, one thing that you could do is that you can make that pointer point at an employee object, or even at a supervisor object for that matter, because the is a relationship goes up, up the whole hierarchy. So we're going to see in chapter 12 that you can do things like take a pointer of the parent class type and point it at a child class object. So meaning, you can do things like person star PTR equals address of employee object, or even person star PTR equals address of a supervisor object. So we can do, but the reason why those things are possible to do, and the book sometimes uses phrases like aiming a base class pointer at a derived class object, or aiming the other way would be aiming a parent class pointer at a child class object. But the reason why those things are possible is because is a relationship, right? That's why all those things are possible. So it's perfectly fine to, and what we're saying is that it's perfectly fine to invoke this operator equal at the person level and pass in an employee object. But the only reason why that's okay is because an employee is a person. An employee object has a person part. So it's going to know how to handle that, right? Of course, when we think about passing the employee object, what we're really saying is that it's the person part of the employee object that we're dealing with when we're actually inside of operator equal for the person class. Because of course, operator equal in the person class doesn't know anything about the employee class or its member variables, but we're working with the person part of the two employee objects and copying the name and the age from one over to the other. So that's what has to happen here for us to be able to truly copy everything from one employee object to the others. We also have to make sure that we copy the person part. So by putting that person : that definitely is going to force it to call the person version of operator equal. And then the two things that we're passing in are going to be the two objects, right? The current object and then the the other employee object here. And again, this is just kind of the most concise way, really, of doing it. So just person : and then write this out as a function call, where we already know it's implied that the current object is the the one that's passed to this pointer, and all that, and then the other would be E. In the comments here, there's some description, but then this kind of thing is also okay as well, right? A little bit of a more involved way of writing it out, but basically, this is trying to do it without writing it out as a function call syntax. But the idea is that we know that the left-hand object is the current object, the one pointed out by the this pointer. The right-hand side is E, the other object, the one that was passed in. And then the goal would be to call, of course, operator equal in the person class rather than the in the employee class itself, because that'd be recursion. So what's also happening here is just a cast type statement. So static cast and then person ampersand. Because right, ultimately, you're calling operator equal with either of these, right? You're calling operator equal in the person class. This is trying to do it without function call syntax, meaning just using operator equal, similar to how we did it like with the chord class. But you still need to think about how you're going to ensure that it's going to call the person version of op equal instead of the employee version. Because if you just did something like star this equals E, well, that's just going to call the most local version, right? That's going to call the employee version. But by doing the cast statement right now, because we're really, in effect, right, we're taking the current object here, casting it to type person ampersand, and we can do that type of cast because an employee is a person. So we can cast, right, an employee, something of employee type to something of person type because of the is a relationship. And it's also person ampersand, right? So meaning reference, right? Reference to a person object. Because we also want to be ensured, right, that changes that take place inside of the person level of op equal are still going to be reflected back at the employee level. And it's a good idea also, just, we have to do it here, but in general, we've said that usually we try to avoid making copies of objects, when it's possible, at least, to do so. But it definitely, in this case, needs to be casted as a reference type, right? Because otherwise, if you just cast it to type person, then it's going to create a copy object, right? And then the copy object is what you'd be changing at the operator equal function at the person level, right? But by casting it to person ampersand, it means that you're still working off of the current object when you get to operator equal at the person level. So meaning when you do the statements like the age and name, instead of passing in, so meaning, when we think about things like the this pointer, if you cast it to type person, then you're creating a new copy object, right? So you're also invoking the copy constructor and all that, but you're invoking a copy object, which is then passed to the this pointer, and then in that copy object, you'd be copying name and age, right? But you wouldn't be copying it to the original employee object, right? Or the person part of the original employee object. But when you cast it to type person ampersand, now it means instead of creating a new person object through the copy constructor, it's just going to reference the person part of the employee object. So it means that these statements, the age and name statements, it's going to be updating them for the person part of the original employee object, meaning the left side employee object, the one that we're wanting to change here. So that'd be another way of doing it, but the first way is a little bit more convenient. But But either way, the whole idea is we have to trigger a call to operator equal at the person level. But the nice thing about just writing it out using function syntax here is, at least since it's a member function, we already know that the current object is automatically going to be passed to this pointer. So the only parameter here would be E, meaning the other object, the one that's not the current object. So that's the way that's active, right? The one with the function call syntax. But then this is just kind of showing the idea of the other way of thinking about it. So using a cast here, where you'd have to cast it to person ampersand, and that's going to force it to call it at the person level instead of at the employee level. And then when that's done, regardless of which way that you implemented it with, when you come back from that call, meaning when operator equal at the person level finishes, then the only thing that's left to do is to copy the ID and the salary over from the other object to the current object. Oh, okay, yeah, sure, no problem. So we still have to ultimately do things like ID equals E dot ID and salary equals E dot salary. It's just we're doing that after dealing with the person part, right? Because similar to how it worked with the constructor, right? We know that when we're creating a child class object, the first thing that happens in the member initializer list is you call the parent constructor. And, in the same way, you really should deal with things from the top to the bottom, right? So before you copy the ID and the salary, you really should be copying the person part first. So that's why we have that statement first. Copy the person part from one employee object to the other, do that first, and then we come back and deal with the ID and the salary directly here. So that gives you an idea of how this whole idea works, right? How we can combine things like inheritance and operator overloading. Just a matter really of making sure that you call the function from the next level up and that you call it in the correct way. So again, thinking about things like what it is that you're really passing in. So that's why with the other way of doing it, it's important that you casted it to a reference type instead of a value type, meaning something like static cast person instead of static cast person ampersand. Because then when you do that, when you cast by value, you're making a whole new object. So in that sense, it was a little bit more convenient just to have this version up here active. And then we copy them over and then return the current object. And here, output operator, same general idea, but a little bit of a difference, only in the sense that, so up here, we were able to use the scope resolution operator because it belongs to the person class, right? So that's how we know, even though this is, for example, E here, that's how we know that we're calling person version of op equal, because it's part of the person class, right? Now with the output operator, that's not the case, because it's always implemented as a friend function. We know that it's going to be implemented as a friend function because the first parameter is not the class object, right? It's a reference to cout. So certainly, we're not going to be doing things like person : operator less than, right? But nonetheless, you can still use either form here. It just, it won't be through the scope resolution operator. So again, we have one of the ways active here, but the function call syntax could be something like this. So operator less than with the full word operator written out. And then the first parameter would be output. And then you still would need to think about casting the second parameter, right? Since there's no scope resolution operator, in terms of what's going to be called, it's going to depend on the types of each individual argument. So of course, if you just said something like operator less than output E, well, then that would be recursively calling operator less than in the employee class. So you still have to think about casting here. So, but the function call syntax would be like that, and then static cast, and then we'll talk about the constant, but we're casting it in this case to type const person ampersand, or reference to a constant person object. Or you can just do it like what we did up here. So either way, there's going to be a cast type statement, since there is no scope resolution operator. So that's the only way that we can distinguish between, are we calling the person version of the output operator, or are we calling the employee version of the output operator? And of course, we want to call the person version because we don't want to be doing infinite recursion and all that. But so with what we have active here is not using function call syntax, but we did show what that function call would look like down here in the portion that's commented out. But so what we have active is output, and then we have the first less than operator, and then static cast const person ampersand E. So this is the first, right, regardless of what syntax we use, whether it's function call syntax like this or not function call syntax like this, either way it's a function call, since we know that operators are functions. But the idea is that we're calling, with this first function call, the left operator, or the left operand, is output, which references cout. And the very important thing is that we make sure that the right operand is of person type rather than employee type, right? Otherwise, we're going to certainly have big problems. But we're doing that with a cast statement here. But notice in particular how we're casting it, because this is a little bit different than what we wrote in the comments for op equal. A little bit different, but almost the same. But here we also have the word const, because it says static cast const person ampersand E. But we can think about why we're doing it that way. Why are we, for example, why are we saying const person ampersand instead of just, person ampersand, instead of something like this? Well, first of all, we have to think about the difference, right? If we just were saying cast it to type person ampersand, then that would mean we would be able to change, right? So for example, when we call, the person object, then we would have that potential of being able to change it. But we know that with output operator, the object is always treated as constant, right? And that's why in the, the parameter list, we have const, and we have the same thing also at the person level. So it needs to be passed by as constant here if we're going to be passing it by reference. So that's why we got that error there. That would also work, but because just like when you think about any function call, right, we know that if you pass something by value, of course, it's not going to change the original object, but then the downside is, just like we talked about back in chapter 9 and chapter 10, that whenever you, for example, call a function and pass an object by value, right, you make a copy, right? You end up invoking the copy constructor. So if you pass it by value, that kind of thing also can work, but then you're creating another copy of the person object. So you're taking up some more memory. So, but if you cast it to constant reference, then you can avoid making an additional copy object. So that'd be the advantage there. But either way would ultimately work. But you'll just create another copy object if you do it by value. But that's the first function call. And since we are casting it to something that's related to the person type, now it's going to know, oh, we're calling actually the output operator in the person class, right? Not trying to do a recursive call to output in the employee class. And so then, right, we're going to call that function. And that already is building the stream with the name and the age, which is good because we want that to be outputted, right? When we output an employee object, for example, in the application program, we want to see everything, the name and the age and the ID and the salary, right? All four things. So this is building a stream, right, with the name and the age and then returning it back. And then from there, we can directly deal with the ID and the salary, right, when we continue with the rest of it, which is exactly what we did here. So after this part, then we have some remaining calls to operator less than, but we just directly refer to ID and salary. And so we're going to get the whole thing by doing it in that way. So just in this case, use either syntax, but either way, you're going to, since can't use things like scope resolution operator, we're going to have to cast it to distinguish it from, person type versus employee type. So we just have this version here active, but that's going to build up the stream. And then the rest of this is similar to things we've seen in the other inheritance example. So in particular, the employee constructor, the first thing that it does, if you look at the member initializer list here, the very first thing that it does is it calls the person level constructor, passing in the arguments for name and age, right? So that's why, because remember this constructor here at the employee level, similar to what we did at the person level, it takes in all four arguments, meaning arguments for ID and salary, which would be the last two, but also arguments for the things from the person class, meaning the name and the age, right? All four of those are passed in. So the very first thing that needs to happen before anything else is we need to call the person constructor in the member initializer list. Because of course, when we do that, right, we're going to call the person constructor, and that's going to initialize that part of the object, initialize the name and the age for the person part of the employee object. And then there's an output statement here too. But then when the person constructor finishes, then we go back to the employee constructor and we just pick up right where we left off. So we initialize the ID, we initialize the salary, and then we will also see this output statement that says employee constructor. And then the print message function, again, that was just a little extra thing that we included to do some basic tests. But the idea is that we're doing a couple of things here, actually. So inside the body, we're calling print message from the person function or from the person class. Since it's a member function, we can just do that with just using the scope resolution operator, so we don't have to write a cast statement out or anything like that. But so here, similar to what we've seen with some of the other examples, we can always call when the same function is implemented differently at both levels, or possibly more than two levels. We can use things like the scope, assuming it's a member function, we can use things like the scope resolution operator to call the correct version. So the employee print message, first thing it does is call the person print message, and then it turns around and it prints out this thing that says employee message after the function call ends. And then the employee destructor just has a cout statement. Again, there's no dynamic memory or anything like that, so there's not anything that really has to happen in the destructor in this case. So now we haven't looked at the supervisor level yet, but now we're starting to see the basic idea. And it'll be the same idea once again when we get down to the supervisor level. but we're seeing it, it's actually pretty straightforward in terms of what you need to do to make operator overloading work when you have inheritance, right? It just comes down to ensuring that you're able to trigger the call to the right version of that overloaded operator. And we saw that, we've seen a couple of different ways that this can potentially be handled, right? Depending upon whether it's a member function or a non-member function. Again, with something like the output operator, since it's not a member function, we're going to have to do some sort of cast type statement. So we saw that you could, again, just cast that ideally to a reference type, right, instead of a value type. So that way you don't make an extra person copy object. So ideally, cast it by constant reference instead of by value, using either this type of syntax or function call syntax, either same thing either way. But and then with the assignment operator, you could do it, since it was a member function, you could just simply do it with the scope resolution, right? So that's why there's we didn't have to do any type of casting type statement here, since we just used the scope resolution operator. And then, as we discussed, we know that it's okay to do that because an employee is a person. And as we've kind of been hinting at, because of how tight that relationship really is, that's why, and we'll talk about the whole idea behind polymorphism, but that's why you're able to even do things like take a pointer of type person star, right, and make it point at an employee object, or make it point at a supervisor object, or take a pointer of type employee star and make it point at a supervisor object. So those things are all possible because of how tight that inheritance relationship really is, in the sense that an employee object literally is a person, right? Which is the entire basis of chapter 12, right? Polymorphism. But that's why these things that we're seeing are all possible. But it's important to also note that, you can't go the other direction, right? Like, so, like we were saying, when you think about operator equal inside of the person class, well, first of all, we don't even know inside the person class anything about the employee class, right? Because that's the top level class. So we're not going to be able to do things like, try to, for example, call operator equal from the employee class inside of the person class, because a person, is not an employee, but an employee is a person. So we can go in that direction. So that gives gives us an idea of what's possible versus not possible, when we just take into account what the is a relationship really means, and the fact that it is important to remember that it's a one direction relationship, right? Not a mutual relationship. So an employee is a person and has a person part, and therefore it's fine to do things like call operator equal in the person class with the employee object being passed in, but it's not fine to try and go the other direction and do things like inside of the person class, for example, or person operator equal, try to call operator equal in the employee class and then pass in the person object or something like that, right? Because the is a relationship does not go in both directions. So it's a matter, really what this whole thing comes down to, though, in terms of combining operator overloading with inheritance, just a matter of one way or another calling the right version of the function with the right type of argument being passed in. So with operator equal, again, you can just, since that's always going to be a member function, you can just do really this kind of thing. Although the casting approach also works as long as you cast it to a reference type rather than a value type. And then, as we saw, if it was not a member function, can't use the scope resolution operator, but you can still cast it to make sure that you are able to still call the right version of the function. And that's really what it comes down to, right? So it's very straightforward in terms of how we can bring these two ideas together, right? How we can combine operator overloading with inheritance. And then after the break, we'll look at the supervisor level, and then we'll start to look at the application program. So any questions here before we go to break? Okay. Okay, so we'll take about a 12-minute break till 1:12, and then we'll come back. 12-minute break, and then we'll come back at 1:12.